Hi guys, we're going to go ahead and take a look at our data and make a connection between the shape of the distribution, both with histograms and box plots, and how the data of the mean and the median and such compares. We'll also take into account the spread that goes along with that. So before we do that and we get into the actual matching, let's recall that when we have data that the mean is less than the median, okay, then we've got something that will be shaped where we have that skew to the left, okay, because that mean is pulled in the direction of the skew. So remember that less than has that left skew. Likewise, if we have that greater than, mean is greater than the median, then we've got that skewed to the right over here because we've got that greater than symbol making that mean pull up. Now, if they're approximately the same, pretty close to each other, then the data will be somewhat symmetric, okay? It could even, it could be this, all right, but if that mean and median are pretty much this, or very similar, then they're going to have somewhat symmetric. All right, so what we have here is our cards that we used before, and I've got data that is skewed left. Okay, I've got these ones skewed left, somewhat symmetric, and then skewed right. And I have over here on the left data cards. And so when I take a look at a data card, then what I'm going to be looking at is this relationship between the mean and the median. And that will be the first thing that I'm looking at. So in this case, I can see that the mean is greater than the median. So then that tells me I'm going to take this and put it over here in the skewed right section. So here, the mean is approximately the same as the median, so that's going to go in our somewhat symmetric section. So I'm going to go through all those data pieces. This one, they're pretty close to the same. Here, the mean is less than the median. That's skewed left. Mean is greater than. So I'm going to probably put that over here in our skewed right. Okay, and so on. These are about the same. That's going to be in the symmetric. Those are about the same. That's going to be in the symmetric. And these ones are the mean is less than. Okay, so I first separated out my data in terms of left, somewhat symmetric, okay, and then skewed right. Now let's take a look at these histograms. Again, if the histogram, see here I have the tail on the right. So I'm going to put that over here in the right. Here's another skewed right. Let's look at this box plot here. So I'm kind of looking where the stretch is. And here from the median to the right, that is a stretch to the right. So I'm going to put that to the right. What's this one? Okay, see here, I have more of a stretch on the left side, so that one's going to be over here in the skewed left. That one's somewhat symmetric, so I'm going to put that in the middle. This here, somewhat symmetric, okay. Here is I can tell it's more stretched out to the right, so I'm going to put that with skewed right. Here, stretched to the left, so I'm going to put that with my skewed left. Skewed to the left. And let's see what we got here. That one looks somewhat symmetric. Somewhat symmetric. Symmetric. Let's see what else we got. Oh, this one here, more to the left. Skewed to the left. Somewhat symmetric. That one, somewhat symmetric. I'm going to go with that. What do we have here? Somewhat symmetric. Let's see. Okay, I think that's it. So what we should have is 2 of the skewed right ones, 2 of the skewed left ones, and then 4 in the symmetric. Okay, so now we're going to match these up accordingly. So let's just take a look at these ones over here on the left. Okay, so now I'm going to kind of scoot these over a tad. Let me move my center ones over a tad. Okay, so now, in fact, I'm going to just kind of get them all bunched together there, and all of the right ones bunched together. Okay, so now over here on the left, let's take a look at what we've got going on. I want to take a look here, and now I can really evaluate. Another indicator to me is going to be the spread. Okay, so here in this case, I can tell a big difference between the spread of these two sets of data. Okay, so I know that with this standard deviation of 30, it's much bigger spread than that standard deviation of 17. So between looking at these two box plots here, which one is more spread out? And that's definitely going to be this one, the box plot C, and box plot D is less varied. So I'm going to do that same philosophy or that same idea with these. Between these two histograms, it looks like this one, third one here, or histogram 3, is not as spread out as histogram 2. So that is then going to be my set of histogram, box plot, and data that goes together. Now let me just kind of make this connection to you. Do you see this, a lot of data right here? Those correspond to a small whisker and a itty bitty small box, because there's a lot of data in a little bitty amount of space. So that's why that box is so condensed. Okay? Whereas here, there's a lot of data spread out. So that's why that whisker is that bottom quarter of the data. This bottom 25% is more spread out. Okay? All right. Now let's do the same thing with the right. The right is probably going to be, it's easier when we have these little sets of, there's just two to compare. So on this one, I've got a standard deviation of 19 and a standard deviation of 21. Those are closer together, so it may be more difficult to tell. Let's see. So between these two histograms, I'm going to say that histogram 1 is definitely smaller spread. So I'm going to leave that with 19. And histogram 7 is a larger spread, definitely more spread out. Okay, these on the left are more closely clustered. Now let's take a look at this box plot. See, I can tell with this box plot A, I've got some good condensed values right here. That's going to correspond, I think, I'm going to say that that's going to correspond to this section right here being so condensed. Okay, so these are definitely less spread out. Another indicator is I can tell these are going down to 10 and below, and here's that. This one, the lowest, is above 20. Okay, so there's some other indicators as to why I say that this A goes with this left, more smaller standard deviation ones, and that one's the larger one. All right, so I've got all of that together. Now let's work on these symmetric ones. Okay, so these symmetric ones here, let's see what we got going on. With the symmetric ones, we've got a bit more. We've got 4 sets of information that we've got to deal with. So what I'm actually going to do is I'm going to spread out a little bit more. So let me come on over here and spread out my cards. Okay, here we go. So here's all of our symmetric information. Box plots, histograms, and data. All right, so what I'm going to do is go ahead and put my box plots from, or my data from least varied to most varied. So there's 16 for the standard deviation, 20, 33, and then 38. Okay, so there I have it from least to most varied. 16, 20, 33, 38. Okay? Now, it's easiest to actually do the smallest and the largest. So if I was to just, let's look at box plots here. Which one is definitely the smallest spread? And I can tell that's pretty easy. There's the smallest spread right there. Okay, now between these three, which one's the largest spread? And to me, that looks like looks like G. It's kind of hard to tell, so let me look at those a little closer here. If I'm comparing G and H, it's hard to tell because I have them as different sized. I think I'm actually going to say that H is more spread out. And the reason I'm going to say that is because I have these smaller whiskers. I can tell that my IQR is a little bit more spread out. It is a wider IQR because this one just goes from 20 to 80. This one's going from like 15 to 85. Okay, and I have these smaller whiskers. So to me, that's telling me I've got a lot of data in a little bitty space out there in the whiskers. So I think that one's the largest. Okay, so now let's go with the histograms. And I think that as far as the spread goes, this one here is going to be my largest because this one out of the histograms has the most data on the outside edges. Okay, and that's what's going into those little small whiskers there. I have all of this, and this middle 50% is very spread out. Okay, and then my smallest spread is going to be this one here because I can tell it's just going from 20 to 80, and everything else is wider. Okay. All right, so I got the biggest and the smallest ones set. Now let's take a look at these. Are a little bit harder to tell. So between these two, box plot, which one do you think is smaller spread? And I'm going to say this E. So of these two, the box plot with the smaller spread is E, so G goes there. All right, now of these two histograms, which one is the smallest spread? Well, I can tell this top one has the data more closely clustered to the center because I have higher amounts in the middle. So because of that, then I've got this one is my smaller of the two standard deviations. So with that being said, that then matches up my 5 somewhat symmetric shapes together with their corresponding box plot and histograms. All right, so I hope that helped you kind of understand this connection between all of our data that we have in our histograms and how I would say things. We've got this tall bars on the histogram. They went to little narrow boxes or skinny whiskers. See, these tall bars went with little skinny whiskers or boxes. Okay, and that's what we had here. These tall bars went with small whiskers. Okay, and the opposite was that you have, this wider bars. It took a lot of data. It was very spread out here. So these smaller bars it took a lot wider amount of time. Right here, smaller bars took a wider amount of space to reach that 50%. Okay, and so then that's what that's saying here. You could also tell if they were skewed left and that kind of thing based on the side of the whisker, and skewed right, and also compare it to the data. All right, so I hope that helps you with the connection between histograms, box plots, and their data.